Hello students, I hope you all are fine. Students, as you know that yesterday we were discussing about the concentration terms. We have discussed about the mass by mass percentage, mass by volume by volume percentage, molarity, strength, molality. Okay, so some terms are remaining students. So today we will complete that. Then students, we have done yesterday. First we discussed about solute. Okay, means what is the solution, we have discussed about that. Then students, mass by mass percentage, volume by volume percentage we have discussed. After that, what is molarity, what is strength, and what is molality. So today we will discuss about the normality. Students, what do you mean by the normality? Normality. Normality, it is denoted by capital N. It is denoted by capital N. Students, in previous class we have discussed about the molarity. Molarity, how many moles are present in 1 liter of the solution? That is known as the molarity. But how many gram equivalent are present in 1 liter of the solution? That is known as the normality. So students, normality is number of gram equivalent, number of gram equivalent number of gram equivalent present in 1 liter of the solution. Okay, now student, what is gram equivalent? We will discuss about that. How can we calculate about the gram equivalent? Students, gram equivalent is gram equivalent gram equivalent we can calculate by given mass divided by the given mass divided by the gram equivalent weight. Gram equivalent weight. Or we can say gram equivalent mass. Now students, what is this term gram equivalent mass? How can we calculate gram equivalent mass? Gram equivalent mass we can calculate by using the term gram equivalent mass. We can calculate by molecular mass divided by the n factor, divided by n factor. Now what is the n factor? So with the help of an example we will discuss all these concepts. Here if I talk about H2SO4, okay, let us consider it is given to us 49 gram of H2SO4. So how can we calculate gram equivalent for that? First of all, we should know about the gram equivalent mass here. So gram equivalent mass we can calculate. Molecular mass, first of all we should know about molecular mass of the H2SO4. So H2SO4, I hope you know how to calculate molecular mass. First of all, you will write all elements. Here hydrogen, sulfur and oxygen present. Okay, students, here hydrogen has mass 1, but you can see there are two elements. So mass is 2. Here sulfur, only one sulfur is here, so its mass is 32. And students, oxygen, one oxygen has mass 16, but you can see here four elements, so 16 4s are 64. Now students, you will add all these. You will add, after adding 2 to 4 and 4 8, 6 and 3, 9. So 98 gram. This one 98 gram is molecular mass. It is the molecular mass of sulfuric acid. Molecular mass of the sulfuric acid. Okay. So here molecular mass is 98 divided by n factor. What do you mean by the n factor? N factor means how many H positive ions it is releasing, how many OH negative ions it is releasing, how many electrons it is gaining or it is losing. Okay. So all these things are included in n factor. Okay students. So here H2SO4, if you will decompose it, so it can give after decomposition 2H positive, SO4 2 negative. Means here transfer of 2 electron is taking place. Transfer of 2 electron is taking place here, means here n factor is 2, here n factor is 2. Here n factor is 2. Then students, molecular mass by n factor. This is the gram equivalent weight or gram equivalent mass. So for sulfuric acid, gram equivalent mass is 49 gram. Now if we know about the gram equivalent mass, then we can calculate gram equivalent. So how can we calculate given weight? Given weight is given, what is given? 49 gram. 49 gram is given. So students, 49 by gram equivalent mass we have calculated. So here 49 by 49 is equal to 1. So how many gram equivalents are there? There are 1 gram equivalents. There are gram equivalents 1. Okay. So students, the normality is that how many gram equivalents are present in 1 liter of the solution. That is known as the normality. Now students, you can see, what do you mean by the gram equivalent? Gram equivalent is given mass by gram equivalent mass. Then how can we calculate gram equivalent mass? We can calculate molecular mass divided by n factor. What is n factor? A species, how many electrons it is gaining or losing, means how many electrons are going to transfer. That is known as the n factor. Okay. So here in case of sulfuric acid, n factor is 2. So in this way we can calculate. Now students, if I say if 49 gram of sulfuric acid is dissolved in 500 ml of water, then calculate normality. So students, how can we calculate normality? From here, normality is equal to gram equivalent weight, and gram equivalent weight we are calculating by using this formula. So students, I can write given weight of solute. Here WA is given weight of the solute. WA. This is here WA is given weight of solute. I hope you are getting my points. So here divided by gram equivalent mass. By per liter of the solution, means if solution volume is given in milliliter, first of all we have to calculate it in liter, and first of all we have to convert into liter, and for converting volume from milliliter to liter we need to divide it by 1000. Then student, after calculation we will get into 1000 by given volume. I can write V here. Okay. V is given volume of solution. So students, by knowing this simple formula, we can calculate normality in easy way. Now you will see how can we calculate. So normality is equal to given weight of solute divided by gram equivalent mass into 1000 by given volume of the solution. Here our statement was 49 gram. 49 gram of sulfuric acid is dissolved in 500 ml of water. Then calculate normality. Okay, students. So this is the statement we have. Here you can see given weight. Given weight of solute is 49 divided by gram equivalent mass. How we will calculate? I already discussed about that. Molecular mass and molecular mass of sulfuric acid. We know about that. That is 92 divided by n factor. Here n factor is 2 because it is transferring 2 electron. So gram equivalent mass is 49 gram. 49 gram. So 49 by 49 into 1000 divided by given volume. Here you can see given volume. Volume is given 500 ml. So divided by 500. So students, here you can see here normality will be the 2 normal. But students, if I say calculate molarity, not normality, calculate molarity for this, then what was the formula for molarity? For molarity, our formula was M is molarity, capital M is molarity. It is given mass of solute. So here given mass of solute is 49 divided by molecular mass of solute. What was the molarity? Here? Molarity was this one. Given mass of solute divided by molecular mass of solute into 1000 by, no, it is molality. This one is molality. Given mass of solute divided by molecular mass of the solute into 1000 by given volume. So by putting this formula, we can calculate students. Here given mass of solute is 49 and molecular mass for sulfuric acid it is 98. Into 1000 by given volume is 500. Then students 2 means 1 molar. Students, here what is the difference between the value of normality and value of molarity? You know, there is a relationship between molarity and normality. There is a relationship between normality and molarity. So what is the relationship? Let's see. Here normality is equal to n factor into molarity. This one is the relationship, students, between normality and molarity. Okay, let's consider if I know about the molarity. Okay, if it is given 1 molar of sulfuric acid, then calculate normality for that. So you can calculate here n normality sulfuric acid. So you know very well what is the n factor. Here n factor is 2 because 2 electrons are transferring here. Here n factor is 2. Okay, 2 into students molarity. So molarity given it is 1 molar. Then normality is 2. Normality will be to normal. Okay, students. So here, simply we can, if we know about the molarity of a solution, then we can calculate normality also. How can we calculate? We will multiply value of molarity by n factor. I hope this point is clear to you. Okay, students? Yes. Students, if it is given NaOH, so what will be n factor here? Here, students, it can be decomposed in Na plus OH negative. So only one electron is transferring. So here n factor. Here n factor will be 1. N factor will be 1 only. If it is given H3PO4, H3PO4, then students it can give 3H positive plus PO4 3 negative. PO4 3 negative. So 3 electrons are transferring here. So here N factor will be 3. Okay, so how many electrons are transferring? You can calculate n factor on behalf of that. I hope this point is clear, students. Then students, one more concentration term is here, that is mole fraction. That is the mole fraction. Yes, one more thing here, normality. Normality is also temperature dependent. Normality is also temperature dependent. Students, you will see if volume is there, means it is temperature dependent. So here normality, molarity, these are the strength, these are the temperature dependent. Okay, but molality is temperature independent. But molality, if I talk about molality, it is temperature independent. Because in molality only mass is there, no volume. So it is temperature independent. Sometimes directly these question can be asked, which one of following is temperature dependent and which one of following is temperature independent. So if volume is there, by simple method you can identify. If volume is there, then it will be temperature dependent. Okay, and if volume is not there, then it will be temperature independent. Because student, if we increase the temperature, then volume of the solution will be increases. Okay, you can observe at your home also. Students, when we boil the milk, means when we keep the milk and water at gas stove. Okay, student, and if we lighten up that, then what will happen? After that, the milk will, after some time, milk will start to boil up. Okay, so after some time, milk will start to boil. Okay, and students, it will start to expand and it will start to expel out from the container also. Why it is? Because when temperature is increasing, particles kinetic energy is increasing, so they are moving far apart and their volume is going to increase. So if volume is there, then it will be the temperature dependent, and if volume is not there in any term, then it will be the temperature independent. I hope this point is clear to you. Then one more term is here, that is mole fraction. Mole fraction. Now what do you mean by the mole fraction? First thing, students, mole fraction is denoted by small x. It is denoted by small x. Okay. What is the mole fraction? Let us consider, if I have in one container here, okay, let us consider we have solute particle only. Here we have solute particle and our solute is A. Our solute is A. And is in this container I am having solvent. I am having solvent. And let us consider our solvent is B. Okay. Then students, if I take one more container I have. Then students, if I add an a mole of means an a mole of solute a here in this container. And students, if I take an b mole of solvent, then now you can see here total moles are Na plus Nb. Total moles are Na plus Nb. Now students, what do you mean by the mole fraction? Mole fraction is number of moles. Mole fraction is number of moles present, or we can say number of moles of that component divided by total number of moles present in solution. Total number of moles present in solution. Means if I talk about mole fraction of A, then you know very well mole fraction of A I want to calculate. So mole fraction is denoted by X, and for A I want to calculate, so I can write X A. It will be equal to the number of moles of that component, means the component for which I am talking about. Okay, so I am talking about A here, so number of moles of A, and in this solution number of moles of A are Na divided by total number of moles present in solution. So in this solution total number of moles are Na plus Nb. Then students, mole fraction for A will be Na by Na plus Nb. And if I want to calculate for B, then I can denote by Xb. So number of mole of that component means number of moles of B. So Nb divided by total number of moles. Total number of moles are Na plus Nb. Okay students, so here always total mole fraction of a solution will be unity. Either there may be 2 components, 3 components, 4 components, whatever. Okay, but the total mole fraction of solution will be always unity. For example students, here this is mole fraction of A only, this is mole fraction of solute only, and this one is mole fraction of B. B means solvent, means this one is mole fraction of solvent only. So if I talk about mole fraction of this solution, let us consider this is X. This is X. So I can write students X is equal to XA plus XB. Then you can see XA is equal to, consider it 1 and it's 2. So XA is equal to Na by Na plus Nb plus XB. Value of XB is Nb by Na plus Nb. Okay. Then if you will calculate, what will happen? Then take LCM. Here LCM is Na plus Nb. So from here Na and from here and B. Then students, we can cancel and it will be equal to the 1. It will be equal to the 1. So I can say that mole fraction for a solution. Mole fraction of a solution is always unity. Is always unity. I hope this point is clear to you. Okay, students, one more thing. Mole fraction is unitless. Mole fraction is unitless. Unitless, or we can say dimensionless. Means it do not have any unit. You can see here at upper side, means as numerator we are taking moles, and as denominator also we are taking as moles. So moles by moles, they will cancel each other. So overall no unit there. So they are the dimensionless. And students, mole fraction is always, it is also, because here only mass, only moles are there, no volume. So it is also temperature independent. Okay, students. So mole is of such one will be unity. Mole fraction is dimensionless. Means it has no unit. It has no unit. Okay, and mole fraction is temperature independent. So students, molarity not. What is the note here? Molarity, normality, and strength. And strength. These are the temperature dependent. These are the temperature dependent. But students, if I talk about molality, mole fraction, and mass fraction, are, these are temperature independent. These are temperature So this is the important question. Okay, students, so you will keep in mind. So students, today we have done concentration terms. Tomorrow we will discuss some numericals based on this topic. Okay, so I hope this is clear to you. Thank you. Have a nice day.